Uh, So the agenda I'll be covering is the introduction, motivation, then a proposed methodology, experimental result, conclusion, and future enhancement. The last is the reference. So with the introduction, I would like to start about what is autism. So autism is it's a spectrum disorder. It is a neurological disorder which affects the autistic child with the emotional, physical, and social health of the individual. Though the autistic children looks quite similar with the normal children, but their activities is different than the normal children. So the autistic children are quite very sensitive to the different sensory inputs. Like if there is a very loud noise, they close their ears very often, and they are very disturbed if they hear a very large, very high volume or the sounds. Similarly, if there is some fluorescent light that flickers or fluttering of the curtains and posters or wall hangings, they close their eyes because it upsets them, because they are very sensitive to these sensory inputs. With the current, whatever the before researchers that they have shows that before a meltdown of any autistic children, they exhibit some contraction of distress, like which the involuntary cues of anxieties like banging head, scratching themselves, and wrist biting, kicking, closing eyes and ears, and flapping hands, etc. This can be observed before a meltdown occurs with the autistic children, which affects the parents also to handle their children. Here we present a novel approach to identify these gestures by identifying the person pose estimations technique, and built a gesture classification model using supervised learning. So it will help the parents basically to handle their children whenever they are going for before a meltdown. So with the proposed methodology, with the first step, we capture the input images through a webcam, and it fade into the framework. And the architecture here is broken into two stages. The firstly, it is for the person pose estimation, and the second one is the gesture recognitions. The output here gives us two classification with closed ears and closed eyes. So with the first architecture, that is person pose estimation. So here we have taken the COCO datasets and have used the CNN model with ResNet 101 backbone with a batch size of 8 images with 30 epochs. And here it predicts the key points belong to a particular person in the image. Which uses the hybrid classification and regression approach by producing the heat maps and the displacements. And later we also used short range offset, mid range pairwise offset for the post estimation model, and also the person segmentation map and long range offsets are used in the instance segmentation module to produce the different pose estimates for the 17 key points of the body, which is later on used for the second architecture, that is the gesture recognition model. So with the second phase of the framework, here we have taken the 17 pose key points which we got from the person pose estimations, and these 17 points are used here as a feature vector, and we do the Euclidean distance uh, um, for the gesture classification model, and the distance are used as a feature to build a binary classification model here for the closed ears and closed eyes. The different classifier modules have also tried here, such as logistic regression, k-nearest neighbor, support vector machine, and random forest. But with our experimental result, uh, to validate our proposed method, we have chosen 20 images as our test data sets, each for close ears and close eyes from the COCO data sets. So images were here first optimized by the image processing technique to sharpen, brighten, and remove the blur in the images. Then the images were fed into the person pose estimation, followed by the gesture recognitions. So here we can see the machine learning methods comparisons with a k-nearest neighbor classifier, which gives us the precision of 83% and recall of 57. With the support vector machines, we are getting 83% of recall and 57% um, 83% precision and 57% of recall. Logistic also gives us 43% precision and 43% recall. And finally, the random forest gives us good precision and recall of 83% and 71%. And where we can see the F1 score also is highest among the rest three methods. Okay, so here we conclude that among these three classification technique, random forest technique has the highest precision and recall. So we chosen the random forest as the best classifier model for predicting the gesture recognition in autistic children. So here the proposed model outperforms the previous research in performance, that here we don't need a training data set for gesture recognition, as it's purely based on pose estimate features. So in the future scope would be involving adding more gesture classes, and also it will include speech and video to calculate the gesture in real time, and also add an alternating mechanism to intimate the parents as well as the teachers for a meltdown. These are the references we have used. Thank you so much.